All right, 2.5, this is part 1 notes. We're going to talk about the fundamental theorem of algebra. This just states that whatever our highest degree is, that's how many zeros we're going to have. So we've kind of been doing this for the last few sections. So if I have x to the 5th power, I know that I'm going to have 5 zeros. Or 5 solutions. So some of those zeros can be real, some can be imaginary, but we know that we're going to have 5 of them. So with 2.5, there's going to be different ways that we can leave our answer. If it says to find the zeros, then it just wants x equals whatever our zeros are. But if it says to write your answer in linear factorization, it wants it written as the factors. So if my zeros were, let's say, 5 and -4. In linear factorization, I would say x minus 5, and what else? X plus 4, perfect. So remember, it's always x minus the 0, or the solution. So if it was x minus -4, it turns into plus. So this is linear factorization. So it's just a different way of writing the answers out. It's just writing it as the factors. So WebAssign is going to ask you for both ways on the homework. It'll say, some of the questions will just say find the zeros, so that'll just be x equals. Some will say write the zeros in linear factorization, so it wants it written as factors. So the first few examples just have different examples with different degrees, so we can see. So to find the solution for our first degree polynomial here, we would set f of x as 0 and just solve. How many solutions are we going to have here? 1. It's x to the 1st power, so we just have one answer. I'd add 2 to both sides, so x would equal 2. So that would be our one answer. How many solutions are we going to have for b? 2 solutions. So I'd make f of x 0. Here we can just factor. What are 2 factors of 9 that add to -6? -3 and -3. So we have x minus 3 and x minus 3 equals 0. So what would x equal? 3 and 3. So we do have 2 answers here. It just so happens that they're the same answer, but that still counts as 2. We just have multiplicity here. How many solutions are we going to have for C? 3. We're going to have 3 answers. So what would we do first here? Take out an x. We have 0 equals x times x squared plus 4. Now can we factor this anymore? Can we? Why not? Because it's not -4. It's not the difference of squares. It's a plus. When there's a plus in between your 2 perfect squares, you cannot factor it anymore. But from here, we can just set each one equal to 0 to solve. So we have x equals 0 and x squared plus 4 equals 0. So x equals 0 is going to be one of our solutions. We've got 2 more left to find. For x squared plus 4 equals 0, I'd subtract 4 on both sides. So x squared equals -4. What should we do next? Square root both sides. X equals plus or minus 2i, perfect. So this would be our other 2 solutions here. We said we were going to have 3. We have x equals 0, 2i, and -2i. You can leave it as plus or minus. I just wrote it out to show you that we've got 3 solutions here. But plus or minus is fine. Any questions here? Let's do D. How many solutions are we going to have here? 5. So we set f of x as 0. What should we do first to solve? Awesome. Let's take out our GCF, which is x to the 3rd power. We're left with x squared plus 9. Can I factor this anymore? No, it's not the difference of squares, so it cannot be factored because it has a plus sign. So we're going to set each one equal to 0. We have x cubed equals 0. So if x cubed equals 0, how many x equals 0s do I have there? 3. I've got 3 of them. X equals 0, x equals 0, and x equals 0. Again, you don't have to write it 3 times, but we have 3 of them. How many answers do we have left to find? 2. So it just helps to know that that's 3 of our solutions. We've got 2 more left. So x squared plus 9 equals 0. Subtract 9 on both sides. X squared equals negative 9. What should we do next? Square root. So what does x equal? Plus or minus 3i, perfect. So these are our other 2 solutions. We have positive 3i and negative 3i, and we had 3 x equals 0s. Next page just talks about how another way that we can leave our answer. So we're going to talk about something that's irreducible over the reals. When we write our answer in factored form, sometimes on WebAssign or on the next test, it'll say to leave your answer irreducible over the reals. This means that it does not want i's in our answer. So it only wants real numbers. So only real numbers. So when we write our answer in factored form, instead of writing it like in the example down below as x minus I and x plus I, when we leave it irreducible over the reals, we leave it the step before we get the i's, so that x squared plus 1. So this would be irreducible over the reals. If it wants your answer irreducible over the reals, we'd leave it in factored form as x squared plus 1. So no imaginaries. So on the next page, it just talks about different ways that we can leave our answer. So it factored x to the 4th power minus x squared minus 20 for us as x squared minus 5 and x squared plus 4. If I were to solve this, I'd set each one equal to 0 because we can't factor these anymore. So x squared minus 5 equals 0 and x squared plus 4 equals 0. Add 5 to both sides. X squared equals 5. What do we do next? Take the square root. So what would x equal? Plus or minus square root 5. Perfect. Let's do the same thing for the second one here. I'd subtract 4 on both sides. So x squared equals negative 4. Take the square root of both sides. So what would x equal? Plus or minus 2i. Awesome. So here are our 4 solutions. We have positive square root 5, negative square root 5, positive 2i, and negative 2i. Now, if the question were to ask you to leave your answer irreducible over the rationals, irreducible over the rationals wants no i's and no square roots. So no i's and no square roots. So we would have to leave our answer like this, where it was just x squared minus 5 times x squared plus 4. This would be factored form, irreducible over the rationals. Now, if the question said to leave your answer irreducible over the reals, we can put square roots in it. So I can write my factored form with square roots, but I can't write it with i's. So irreducible over the reals would be written like this, where it can have the square roots. So x plus square root 5, x minus square root 5, but I can't write the factored form out for my i's. So I'd have to leave it the step before, which was x squared plus 4. And then lastly, we have completely factored form. So this just takes all of our zeros and each one gets its own parentheses. So that would be x plus square root 5, x minus square root 5, x minus 2i, and x plus 2i. So this is completely factored form. So just pay attention to the way that WebAssign and the way that the tests ask the questions. Pay attention to the wording. If it's irreducible over the rationals, don't put i's and don't put square roots in your factored form. Go back to the step before that you got those i's and the square roots. Irreducible over the reals, you can have square roots but no i's. So it has to be real. And then completely factored form, every term, every answer can get its own parentheses. Bless you. So we want to write the complete linear factors and then state the zeros. So first thing we need to do is find our solutions. So f of x I'm going to change to be 0. What could I do to find, well, how many zeros are we going to have here? 4 zeros. What could we do to find our zeros? Let's take out x first. So we have a GCF of x, so I'm going to take that out. We're left with x cubed plus 3x squared minus 13x minus 15. Now, you do have 4 terms, so you could try grouping, but grouping's not going to work here. Remember, if you were going to group, the inside parentheses have to be exactly the same. It doesn't work here. So if grouping doesn't work, what else could we do? What did we do on the test yesterday? Synthetic division. We want to do last over first. So I'm only looking at doing last over first for these terms here. That x that I took out, I already know that that's going to be one of my solutions, that x equals 0. So we only have 3 left to find. But if I take out a GCF, you can set that equal to 0. So x equals 0 is one of our answers. Now we're doing last over first with whatever's inside of our parentheses. What are factors of our last term? 3 and 5, so plus or minus 3 and 5. What else? 1 and 15. Anything else? Nope. Over factors of our first, which are what? Just plus or minus 1. So inside of my parentheses, I have 1, 3, negative 13, and negative 15. Not missing any terms, so we're good to go. We don't need to put any zeros in there. What do you want to try first? Sure, let's try 3. So I'm going to drop down the 1, multiply, we get 3, add 6, multiply 18, add, this would be 5, multiply 15. Does it work? Yes. So I'm going to add that to my solutions. X equals 3. How many solutions do we have left to find? 2. So once we're left with just 2 left to find, we can, bless you, we can factor. So we have x squared plus 6x plus 5. Do we have 2 factors of 5 that add to 6? 5 and 1, perfect. So x plus 5 and x plus 1. So what would x equal? Awesome, negative 5 and negative 1. So I'm going to add those to my list here too. Negative 5 and negative 1. So these are the zeros. This answers the second part of the question when it says state the zeros. These are our zeros. First part of the question says to write the complete linear factorization, complete linear factors. So I just want to write these in factored form. So I'm going to start with 3. We'd write x, what would come next? X minus 3, perfect. It's always x minus the number. What would come next? X plus 5, awesome. And then x plus 1. How do you think I would write the 0 as a factor? Just x outside, perfect. We wouldn't say x minus 0, that would be silly. Just x outside. So f of x equals, this would be our complete factorization here. Now we don't have any i's, and we don't have any square roots. We don't need to worry about it being irreducible over the reals or rationals. This is just our complete factorization. So WebAssign is going to ask you for these 2 things on some of the questions. It'll ask you for the zeros. It'll ask you for the complete factorization. Just make sure you read the directions. Any questions here? Let's do 2. What could we do to find, how many zeros are we going to have for 2? 3. What could we do to find our zeros? Last over first. You could try grouping here since we have 4 terms, but it's not going to work. So 0, I'm not going to rewrite it. Let's just write our last over first. Last over first. What are factors of our last? 4 plus or minus, you said 4 and 40?
I said 1 and 40.
Oh, 1 and 40.
And then
4 and 10. 2 and 20. 8 and 5. Anything else? We can start with these for now. I think that's all of them. Over factors of the first, which would just be 1. So we're just dealing with whole numbers here. Inside the box, we have 1, -7, 2, and 40. What do you want to try first? We can try 4. So drop down the 1, multiply. We get 4, add -3, multiply -12, add -10, multiply -40. Does it work? Yes. So x equals 4 is going to be one of our answers. How many more do we have left to find? 2 more. What can we do next? Let's try factoring. Since we only have 2 left, let's make this x squared. So we minus 3x minus 10. Do we have 2 factors of -10 to add to -3? 5 and +2, right? Yeah. So x minus 5 and x plus 2. So what would x equal?
5.
And? -2. Perfect. So those would be our other 2 solutions, 5 and -2. So these are all of our zeros. If we were to write this in complete factorization or factored form, how would we write it? X minus 4. X minus 5. And x plus 2. Perfect. Now the order that you write it doesn't matter, because the order that you find the zeros isn't going to be the exact every time, so it doesn't matter how you list them. What can we do for 3? Yeah, but our a is 1, so we just factor it normally. What are 2 factors of 6 that add to 7? 6 and 1. But instead of writing x plus 6 and x plus 1, since we started with x to the 4th power, and our middle term is x squared, it's going to be x squared plus 6 and x squared plus 1. Now, can these be factored anymore? Nope, they're both plus, so not the difference of squares. So let's just set them equal to 0 to find our zeros. So x squared plus 6 equals 0. X squared plus 1 equals 0. I'm going to subtract 6 on both sides, so x squared equals -6. What do we do next? Square root both sides. So x equals what? Awesome. Plus or minus, I'll put the I out front, so I square root 6. Perfect. So that's 2 of our zeros. We've got to find the other 2. So let's do the same thing here. We're going to subtract 1 on both sides. So x squared equals -1. What do we do next? Square root both sides. So what does x equal? Plus or minus, would we write the 1 as a coefficient? No. So just plus or minus I. So here are 4 zeros. If we were to write this in complete factorization, each one gets its own parentheses. We have x plus I square root 6, x minus I square root 6, x plus I, and x minus I. So this is complete factorization. What if this question asks us to leave it irreducible over the reals, meaning that it doesn't want imaginary numbers? How would we write the factored form without the imaginary numbers? Which part? Perfect. So the step before we solved and got the imaginary numbers, this would be irreducible over the reals. Irreducible over the reals means we only want real numbers, so you just take it back to the factored form before you got the imaginaries. So same thing, we want to find the zeros first. What would we do to find the zeros here? Group them. This one grouping works. Again, if you don't want to even try grouping, you could do last over first. Last over first will work too. But here we can actually group them. So what's the GCF from the first group? X squared. We're left with x minus 3. What's the GCF from the second group? Minus 2. And we're left with x minus 3. So remember, in order to group them, the insides have to be the same. So that's why in questions 1 and 2, when you had 4 terms, we weren't able to group them because the insides didn't end up being the same. So here we can actually group them. We're going to put the insides together, x minus 3, and then the 2 outsides are going to go together as x squared minus 2. Can I factor this anymore? Nope. So let's set them equal to 0. So x minus 3 equals 0. What does x equal? 3. Good job, guys. We're almost done. X squared minus 2 equals 0. Add 2. Move it to the other side. X squared equals 2. What do we do next? Square root both sides. So what does x equal? Plus or minus square root 2. So if I were to write this in complete factorization, we've got our 3 zeros here. We have f of x equals what? X minus 3. X minus square root 2 and x plus square root 2. Perfect. So this would be our complete factorization. Now, what if the question said irreducible over the rationals? Irreducible over the rationals means we do not want square roots, so we'd have to go back to this step where it was factored before we had the square roots. So that was x minus 3, x squared minus 2. But if it asked for irreducible over the reals, would be this one also, because this one didn't have imaginary numbers. This is also irreducible over the reals. Any questions?